Hello everyone, welcome to Vijay Codesit. So the topic today we are going to discuss is Catalyst Optimizer. It is also known as Spark SQL engine. Make sure to pay attention on this topic as it is a hot topic for an interviewer. You would be definitely asked one question from this video. Let's get started. So in Spark, we can write code in three ways. We can write code using Spark SQL, using the DataFrame API, and using datasets. So what happens is this code, whatever we have written, goes through a Catalyst Optimizer. You can also say it as SQL engine. And what this Catalyst Optimizer does is it will be creating an RDD lineage. How exactly our code will be getting executed will be decided by the Catalyst Optimizer. Hence, it is very important to understand. Now we have understood what exactly the function of Catalyst Optimizer is. Let's take a look into Catalyst Optimizer, what it exactly contains. So there are total of four phases in the Catalyst Optimizer. The first phase is analysis. The second phase is logical planning. Third phase is physical planning. And the fourth phase is code generation. So let's understand the working of the Catalyst Optimizer in detail. So let's say that the developer has submitted the code for execution. What will happen is first it will go to the unresolved logical plan. Keep in mind that all of these things are happening within the Catalyst Optimizer. So the steps beneath the orange line is what's happening within the Catalyst Optimizer. So as soon as the developer submits the Spark code, it will be going to the Catalyst Optimizer. So first, the Catalyst Optimizer would be creating an unresolved logical plan. So here, the Catalyst Optimizer would be checking for any kind of syntax errors. Once the Catalyst Optimizer has checked for any kind of syntax error, then it would be creating a resolved logical plan. Before that, it would be doing an analysis. So we also have a catalog present over here. So what happens in this stage is the Spark checks whatever we have requested is present in our data. So it would be cross-referencing this catalog. Since the catalog has all the metadata about our data, it will be checking within our catalog. And if we are not able to find that data, it would be giving an analysis exception error. Let's take a live example of what analysis exception error looks like. Here's the example of an analysis exception. I'm taking the example of yesterday's dataset, the COVID dataset. So as you can see that I'm trying to select collection count, which is not present in our group data. So it is giving an analysis exception. As you have seen that in our COVID dataset, there was no column called as collection count, and we got the analysis exception. This was possible because of this catalog and due to this stage. So once the Spark has checked that whatever data we have requested is present within our dataset, then the resolved logical plan would be created. And once we have the resolved logical plan, now what Spark will be doing is it would be doing the logical optimization. So in our previous video, we have seen that when we were filtering twice, but the Spark created only one DAG for that, it clubbed two of our filter steps. This is what logical optimization is. Spark will be understanding what code we have written, and it will be trying to reduce the steps wherever possible. Here I will be taking references of our previous videos, so I will be highly recommending you to first watch our previous videos in the playlist, and then only you will be able to understand thoroughly about how exactly the Catalyst Optimizer works. So once we have our optimized logical plan, then what Spark will be doing is it will be creating a physical plan. Let me give you a brief what physical plan will be. So what Spark will be doing is it will be creating multiple physical plans. Let's say Spark has created two physical plan, physical plan 1 and physical plan 2. So what will be happening now is Spark will be doing is cost based optimization and memory optimization. So wherever we are having our cost as lowest and memory utilizes lowest, Spark would be considering that as the best physical plan. So in physical plan, Spark has created multiple physical plans. Out of those physical plans, now Spark will be choosing one of the best physical plans, and it will be continuing with that. And since now we have our best physical plan, it will be doing is we will be getting our final DAG. And once we have our final DAG, then Spark would be sending the data over the multiple executors. To understand what executors are, again, I would recommend highly to watch our previous videos. So this is what the Catalyst Optimizer consists of in detail. And this is like you must know if you are sitting in a big data interview or a Spark interview. Thank you so much for watching. That's it for today. If you liked the video, please consider subscribing.